to make evaluation for the stuff, to make evaluation for our result, we have to make evaluation after finished all analysis. You ask ourselves, cation and anion balance. Anions and cation balance, it's mean there is in water sample, there is a lot of anions. It's mean chloride, sulfate, phosphate, and so on. Negative charge. We call it anions, negative charge. Cation is positive charge. When we make analysis and make final test report, we just ask ourselves, is there balance in the sample or not? Balance, it's mean number of mole equivalent, total number, summation of mole equivalent of anion equal summation of mole equivalent of cation. We can't find the chloride in water free. Anion without any cation with him. We can't find this form. Okay, this form found in plasma only. But in water, in liquid state, never. We have to support suspended with cation. Cation may be sodium, maybe calcium, but must be mole equivalent of cation in water, total mole equivalent of cation in water equal total mole equivalent of anion in water. Okay? What does it mean, mole equivalent? Mole equivalence, it's mean concentration ratio between concentration of your analyte and equivalent weight of your analyte. Gram per meter cube is the same unit of milligram per liter. Okay? When we finish our analysis, we have to ask ourselves, is the number of anion, summation of anion equal summation of cations or not? We have to collect anions and make summation for anions and make summation of cations and found is the same value or not. If it is the same value, you are good. Your result is okay. Your stuff is okay. Your instrument is okay. Your lab is okay. But if not equal, it's mean there is something error. Something error, maybe some anions you can't catch it. Some cation you can't make analysis for it. Okay, if it is not equal. How to calculate it? If you have calcium, like this, concentration of calcium may be 50 ppm or milligram per liter. Okay, equivalent weight of calcium, molecular weight of calcium is 40. Their charges 2 equal 20. Equivalent weight for calcium equal 20. Concentration of calcium equal 50. So milligram of calcium equal 50. Equivalent weight equal 20. Equivalent weight, it's mean molecular weight of calcium per charge of calcium. So mole equivalent per liter of calcium, mole equivalent per liter of calcium equal concentration is 50 per equivalent weight is 20. Okay, equal 2.5. This is mole equivalent of calcium, and make so on for potassium, for ammonium, for sodium, for every analyte of cations, and make summation for cations, then make summation for mole equivalent of anion. The summation of mole equivalent of cation must be equal summation of mole equivalent of anion. To be sure your result is good, must be mole equivalent of anion equal mole equivalent of cation, summation of mole equivalent of cation equal summation of mole equivalent of cation equal electrical conductivity per 10 divided by 10. Okay, if your result give you this equation by good way, this equation is right for your result, it's mean you have balanced sample. Your sample is okay. And this is charge like sodium, charge is 1. Mass is 23. So we will multiply by 1 per mole equivalent. Mole equivalent will be give us this factor. Concentration of sodium multiply by this factor. Potassium multiply by this factor, and so on.